Hey guys, this is video 6.5. Hopefully you're watching this either in day 2 or hopefully day 3 and kind of working through this. Remember, do not go on to this molecular stuff until you've gone through this video and then you've done all the practice and the lab and taken the Ionic quiz. Make sure you do all 3 of those things after this video before you move on. Really spend the time, and even an extra day if you need to, mastering this skill, because Ionic has many more rules than molecular. Molecular, we will see, goes pretty quick. So let's jump right in. Ternary. Ternary, guys, similar to binary. If binary means 2 ions, what do you think ternary, or 2 atoms, what do you think ternary means? 3 or more elements. Okay, and there's going to be something specific here in ternary compounds that we've already heard the term before, and then you will hear it the rest of the year as well. We're going to be on page 8. Okay, so naming binary ionic compounds, guys, that contain polyatomic ions. So that's the key here, is that we have these things called polyatomic ions. Poly, you guys have heard this term, right? You've hopefully done your vocab at this point. Poly equals many. Oops, my tablet just kind of went off its stand. Poly equals many atoms, or multiple atoms, and it makes up one ion. All right, so polyatomic ion, many atoms make up a single ion. Now, you guys have drawn some of these out in the last unit, things like nitrate, where I gave you the name and things, or like phosphate. Remember, when you made those, you had to put parentheses around the ion itself. So phosphate, for example, looked something like this, with dots all around the oxygens. But if you counted up the number of electrons based on just the elements alone, there's too many here. So then we put our parentheses around it with a charge. Well, guys, these are those ions. You now have to make sure you know their names. But you don't have to memorize them all, and I'm not going to give you a quiz or anything on them. You have to know where they are. Okay? And they're on table E in your reference table. Turn there now, because I want you guys to do this, what I'm about to do. I want you guys to do this on your actual reference table, not just here in your notes. Because their charge is different, like they've gained an electron or 2 or lost them. It's very important, guys, when you write them, just get in the habit of putting parentheses around the polyatomic ion in the formula. When we get into our next unit on reactions and we start balancing chemical reactions and chemical equations, it's going to be important that you kind of can identify these polyatomics and then balance them as a whole package deal. So what I want you guys to do is to take the next minute or so and go through and just put parentheses in your table E, where the charge is on the outside, meaning, okay, that charge goes over the entire compound, not just one single element, but the entire compound, okay? Subscripts are included in those brackets. Now, we can have multiple polyatomic ions in a formula, and we will as we get into some of this practice here, but that goes on the outside. We don't change anything inside in terms of the chemistry of these formulas, okay? They're very unique, so we've got to make sure that we keep them that way. Again, you don't have to memorize them. Some you probably will, okay? I'm going to highlight here in just a second some of those that you probably will memorize, because you'll just see them a whole lot more. So hydronium will be one that we come to later on in the year. Ammonium. Notice there's not really many positives. Most of them are anions, okay? Acetate's going to be one that you'll have memorized probably. Carbonate is a common one. Nitrate for sure, hydroxide, phosphate, sulfate. So those are kind of the big ones. And then this guy, this hydride over here, notice how it's hydrogen as a negative or an anion versus being a positive one. Okay. So those will be the ones you're familiar with. Again, make sure you know where they are. They have their names, so it can be easy for you guys. Notice acetate has 2 formulas there. You could see both, so just be aware. Basically, guys, if you see, and you're naming stuff, if you see more than 2 elements in a compound, this is where you're going to be going, because you know there's a polyatomic ion there. Binary, again, means 2. So if you see 2 elements, it's the rules from the last video. But if you see more than 2 elements in a compound, this video here, these rules are what we're going to kind of follow. Now, if you notice, most of those, the common ones, have oxygen in them. They're called oxyanions. And if you isolate specifically like nitrate and nitrite, this is just kind of a common rule, guys. You don't have to worry so much about it. It's the why behind it, though. Why nitrate versus nitrite. 8 has 1 more oxygen. Ite means 1 less. So nitrate has NO3. Nitrite, that ite, has 2. Okay, so it just is an easy way for chemists to kind of signify, hey, it's 1 less oxygen. Same thing with sulfate. Sulfate has 4 oxygens. Sulfite has 1. So just changing that one little letter, again, changes the chemistry. Okay. Now, if specifically with these ones that have chlorine in them, you can then put a prefix in the term to kind of go a step further. So oxygens that have even 1 less than the ite ion, they have a prefix hypo, okay, like hypoglycemia. Okay, maybe you've heard that term before. Hypo means, oh, it's too low. Okay, where hyper means, okay, you've got a lot of sugar, you're going crazy, you're hyper about it. Okay, so hypochlorite, notice it's got the ite and it's got hypo, which means it's got 1 oxygen, as opposed to chlorite has 2 oxygens. That hypo means it's 1 less. Where chlorate has 3, so chlorate versus chlorite, 1 oxygen difference, and then per means it has 1 more, it's hyper. That's where that per comes from, it's perchlorate. Again, you don't have to know these rules because you have table E. So look at the formulas, okay? Or if they give you the name, go to the table to get the formula. You don't have to memorize them, but that's where those rules come from. Now, in terms of naming the compounds, guys, that contain a polyatomic, it's very similar. It's the same as doing the other ionics, the binary. We're going to put the 2 ions together with their names, and that's it. Okay, but remember, if there's a transition metal, okay, you have to make sure you have the charges. Okay, be sure to check the charges are in your name. Now, one thing I realized as I made this packet, I didn't give you guys a lot of practice. It'll be something we can do. I can give you an extra sheet to kind of practice figuring out the charges, but you have your reference tables. You can figure it out. The thing you want to remember here with your charges for your transition metals, okay, you may have to figure it out. And you should never have to guess. Okay, you should never have to guess. Never have to guess the charge, okay? And here's why. Because you always know the anion's charge, okay? So based on how many anions you have, remember, you got to balance out your you have to balance out your positive and negative charges. So if you know your anion charge and you know how many atoms of that you have, you can then figure out what the charge in your transition metal is. So this is something that we will probably do more when we review at the end of the year, or as I see a need for it, because I forgot to put it in, but you'll see as we go through here and with some of the practice toward the end of the packet, I can work with you guys one-on-one in class when I'm there. To kind of help you with that. But just remember, you don't have to guess. You can look on your reference table, and then based on what the anion's charge is and how many anions you have, that's how you can figure out what the charge would be. So here we go. You've got Na and OH. Bam, right away. I have 1 element, 2, 3. I have 3 different elements, so I know that, hey, there's a polyatomic ion there. So I'm going to go over here to table E and figure it out. Okay, well, when I'm looking at my formula, I know Na. You should know that by now. That's sodium. So that means once you figure it out, guys, everything else goes together. Another way I like to separate this is to draw a line, okay, where my cation ends and my anion begins. And how I know that is, okay, I'm looking for capital letters. Okay, so here's my first capital letter. Once I get to another capital letter, I know that that's a different element. So once I separate it, here's my cation, here's my anion. I'm going to put a parenthesis around those two because they're more than one element. So I know I have a polyatomic ion. I'm going to name Na. That's sodium. Now, if I don't remember what OH is, I'm going to go over here and look. I'm going to scan through everything. Okay, oh, look, OH is right there. So the name of that's going to be hydroxide. So the name of this compound is sodium hydroxide. Okay, let's do number 2 together. oh, I see a lot of capital letters. I see a lot of different elements. There's 3 different elements in here. So I know that there's some polyatomic ion there. So my first step is I'm going to draw my line to separate my compound, my cation from my anion. So I'm looking for capital letters. Here's 1, here's 2. So in between those is where I'm going to draw my line. The thing that comes first, again, is always my cation, K. Hopefully you should know what that is as well, but you can always look it up. Potassium. Now, everything else is part of my polyatomic ion, ClO3. So I'm going to go over here. I'm going to scan table E. I'm going to find that formula. Bam, right down here. That is chlorate. So now this compound is just going to be called potassium chlorate. Okay? Pause the video. You guys go through and do numbers 3, 4, and 5. So I'm going to kind of go a little bit quicker here, guys. This is calcium nitrate. Spelling does count, so make sure that I can understand what you've spelled and that you have spelled it correctly, because we've seen one letter can change the chemistry. Number 4 looks a little bit more complex, so I split it up. There's sodium to begin. And then this guy is a big one. But if I go over here, it's one of the 2 formulas for acetate. So again, you have this, you've got to use that reference table. This is sodium acetate. And the last one, now this one's a little bit more tricky. So if you follow my rule there of, okay, capital letters, and you put it there, well, that's nitrogen. Well, think about it, guys. These are ionic compounds, right? So there has to be some ions in there. You might be thinking ionic is made up of a metal and a non-metal. Well, there's no metals in here. But guys, remember, if you go back and look at your Unit 5 notes, it's made up of 2 ions. We have 2 ions here. This is one of the exceptions where you have 2 polyatomic ions. NH4, if you go over here, and hopefully you looked there and you could figure it out, NH4, guys, is right here. It's one of the positive ones. Most of the other ones are negative, so they're anions, but this is one cation. So this is ammonium as my first piece. Okay, and then NO2, if I look for that, right here, nitrite. Ammonium nitrite. Okay, hopefully you did pretty good. That's going from a formula to a name. Down here, now we're going to go back and use that criss-cross method again, and we're going to just use the polyatomics. So guys, I'm not even going to go through one. You've done this already. Pause the video, go through these 5, then I'll go over them, and then you guys can start working on all that mixed practice there. All right, so ions formed very quickly. K+, hydroxide. Make sure when you're writing these out that you put parentheses around the formulas and the charges on the outside of the parentheses. So when we crisscross, okay, it goes on, the subscript goes on the outside of the parenthesis. So our formula unit here is going to be KOH. Now you will say if you have one polyatomic ion present, you need parentheses. Guys, I would just get into a good habit of putting parentheses around my polyatomics whenever I have them. No matter how many I see, I would just do that with all of them. Next one, ammonium, NH4 plus, and acetate. Doesn't matter which formula, guys, you use. Just pick one. Crisscross method. So NH4 in parentheses. I'm going to put parentheses around my other guy. Again, since there's only one of each, you don't necessarily have to do the parentheses. It's just a good habit to get into. Potassium, K+, permanganate, MnO4 in parentheses with a minus. Just like this. So it's going to be KMnO4. Now, hopefully you remember what that 3 means. That 3 means it's the charge on iron. It's 3+. Nitrate, NO3, has got a 1-. Crisscross these charges. Oh, now we actually have to do a little bit more work. Fe, NO3 is in parentheses, and the 3 goes on the outside. Because remember, this 3 will distribute in. I really actually have total of 3 nitrogen atoms and a total of 9 oxygens. Sorry about that. And the last one, sodium sulfate, Na+. Sulfate is SO4 2-. Crisscross these guys up. Na2, SO4. Okay? So, now, notice what it says right here.
Go on and do practice sheets. I'm sorry, I forgot to change that. It's not practice sheets 1 through 3. It's practice sheets 2 through 4. Okay, do those. Do the lab, guys, the dice lab, as well as the quiz before you go on. Do not go on to molecular naming. I promise you, go through and master this ionic stuff before you move on. It'll make your life a whole lot easier. So long till next time, guys.